for grade 9 under the topic of electricity, integrated science, which is coming from materials and energy. So if you haven't subscribed to my YouTube channel, kindly do so that you don't miss any video I'm going to upload. So it is saying the electric circuit diagram shows cells connected to a resistor R in an experiment. So we have these different components which are making up a circuit, or which are forming the circuit. We have the cells, we have the switch, we have S, which is called the ammeter. So this one is the ammeter. Ammeter is usually connected in series. That is one thing that you have to know. It is connected in series. Whilst the voltmeter, so voltmeter, let me say voltmeter. So for the voltmeter, it is connected in let me do this in parallel. So how do you know that this one is connected in parallel and this one is connected in series? So for parallel, I said this one is connected in parallel. So you have to have something like this. Okay, so let's have an example. If here we are having a resistor, okay, which is R, then we have also another one here. But for the voltmeter, it is going to be somewhere here, which is going to be represented by V. So we have the voltmeter here. So this is parallel. For series, it's just direct like this. Then you have something like this. Then here you're going to have an ammeter here, which is A, represented by A. So this is what I'm talking about. Right. So also have other resistance like this one here, which is the variable resistant. Okay, so the variable resistant or resistor, variable resistor, or you can call it as the most as a resistor in short. Then we have this resistor and the voltmeter, so I'll explain that. So this is the open switch because it is not closed, it is open, so it is the open switch. Okay, so question A is saying define voltage in the electric circuit. So in terms of, if you want to define voltage, you have to use this formula. Voltage is equal to current divided by resistance, this one. So at your level, you can write the formula, they can mark you, or you write the definition, whichever way is very simple for you, they are going to mark you. So in terms of the definition of the voltage, it is the currents, or let me say the current that is flowing in a resistor. Okay, so we are saying current flowing in the current flowing in a resistor. Okay, in a resistor, that is the voltage. Or voltage is current divided by resistant, which is the electric current divided by resistant. You can write that one in words, or you can write the formula they are going to mark you. Then identify the instrument labeled S in the circuit. So that instrument is called the ammeter. Ammeter or ammeter. What is the use of the ammeter? Ammeter is used to measure the electric current. Okay, it measures the electric current, or we can say it measures the electric or current in short. Then how many cells are shown in the circuit diagram? So for the number of cells, the way we count them, you count these parallel lines, a smaller one and the bigger one. So the bigger one and the smaller one, they make one cell. So this one and this one, they are making one cell. This one and this one, they are making one cell. This one and this one, they are making one cell. So how many cells do we have? We have 3 cells. So we have to say 3 cells. Then for question D, it is asking us to calculate and state the ammeter reading at instrument S in the circuit diagram when the switch is closed. So when the switch is open, the answer is going to be 0. That is one thing that you have to know here. The answer is going to be 0 amps when it is open, but when it is closed, meaning to say the current is flowing. So let me just answer it here. So using this magic triangle, the one that you know, you'll be able to come up with the formula that we're going to use. So here we have current, here we have voltage, here we have resistance. So since the question is asking us to calculate the current that is flowing through the conductor or in the entire circuit, so we're looking for this one. So what are we going to do? We have to multiply V and R for us to come up with the formula for us to come up with current. So current is going to be equal to voltage multiplied by resistance. So in this diagram we have been given resistance which is 3 ohms. We also have the voltage which is 6 volts. So we have the voltage which is 6 volts, current which is 3 ohms. When I multiply, I'm going to get 18 amps. So this is our final answer for D. Then E, what would happen to the ammeter reading at S? So this is the ammeter at S. So you can say at S. Okay. So what would happen to the ammeter reading at S if the voltage in the circuit is doubled and the resistance R remains the same at 3? So what they mean here, if we double this voltage here, so meaning to say 2 multiplied by 6, we're going to get 12 volts. So this is the doubling. So what is going to happen to the current? Let's see. So we have 12, then multiplied by 3. Okay. So what we are going to do here is this. We are going to multiply, then compare the value that we are going to get to the value that we already have here. So we are multiplying 12 multiplied by 3. Then this is going to give us 36 amps. So if we compare 36 amps and 18 amps, what is happening here? It is also what can I say? 18 is the half of 36. So it's more like when we double the voltage, we are also doubling the current. So we are going to conclude now. So what the question is asking us now is to conclude. What I was doing here, I was just coming up with an assumption which is going to help us to come up with the comment that we're going to write here. So when current or electric current, not really electric current, let me start with voltage. When the voltage is doubled, the current or the electric current is also doubled. So meaning to say they are directly proportional to each other. When one increases, the other one is also going to do what? Is also going to increase. Right. Then for question F, we're saying what does the result in the ammeter reading at S, or in the meter reading at S in question E, show about the relationship between voltage and current. So this one, it is showing that they are directly proportional to each other. So they are directly proportional to each other. So that was the last one. Thank you very much for watching, and let me subscribe for more videos like this.